with demonstration 4, remember that the cart started off and it was traveling towards the 0 point at the beginning of it, and then it would travel back towards the other direction. So what I know from this is that at some point my velocity is going to change directions. So when I look at my velocity versus time graph, in order to show the change in direction, I need to go from positive to negative or negative to positive at some point. So I'm going to have a momentary stop and then keep going. Well, I know in this case, I actually push the cart towards the 0. So I push the cart in the negative direction. So the cart has a negative velocity to begin with, just taking into account the point after the push until it hits the bumper again. So then I start off with some negative velocity. I know at some time later I'm going to change direction, and that's where my change in direction is going to occur, because then I'm going to move back in the positive direction. So then there's what my velocity versus time graph looks like to show that. I'm moving negatively, slowing down, stop momentarily, moving positively, speeding up, which is what I saw. Now remember then that if I'm going to draw an acceleration, then my acceleration is based on the slope of my velocity time graph. Again, it doesn't matter where my velocity time graph is, positive, negative, doesn't matter. What matters is what its slope is, and its slope is always positive. So then my acceleration for this whole thing is going to be positive. Now, when I look at my free body diagram, I could look at the free body diagram that there was before in demonstration 3. And notice I still have the same free body diagram, and none of the forces changed. It doesn't matter if my object is moving to the left or if my object is moving to the right. Either way, all of the forces on the object stay the same. So because of that, the net force is still the force from the string on the cart. So then when I go to draw my force, it's going to be constant because the force from the string on the cart is constant. So then my acceleration and my force are really dependent on one another. And they show the directionality of one another based on what you see. If the acceleration is positive, that means that your net force is positive. If the acceleration is negative, then your net force is negative.